Hi, my name is Buddy. I'm training to be a magician. I practice all day, but I do not seem to be getting things right. Let me try taking a rabbit out of my cap. Abracadabra. Abracadabra. Sorry. Okay. Let me try doing something simpler. Here's a spoonful of sugar and a glass of water. I'm going to make the sugar disappear. Hocus pocus. See? Let me try making the spoonful of chalk disappear in this beaker of water. Hocus pocus. Oops! The chalk is still there. What did I do wrong?
This lesson is all about types of mixtures. By the end of this lesson, you will be able to identify the types of solutions, list the properties of a solution, define concentration, differentiate between saturated and unsaturated solutions, list the properties of a suspension, list the properties of a colloid, and differentiate between solutions, suspensions, and colloids. Take 3 beakers with 50 milliliters of water in each. Add a spatula of sugar crystals to beaker A, a spatula of powdered chalk to beaker B, and a few drops of milk to beaker C. Stir well with a glass rod. Particles can be seen in beaker B, but not in A or C. Direct a beam of light from a torch through the beakers A, B and C and observe each beaker from the front. The path of light is visible in case of B and C, but not in A. Leave the mixtures undisturbed for some time. Now, filter each of the mixtures. You will find a residue on the filter paper for beaker B. The mixtures in the beakers are of 3 distinct types. The mixture in A is a solution, in B is a suspension, and in C is a colloid.
Hey! I could use this while performing tricks. Tell me more. I'm thirsty. Let me conjure up a bottle of cola for myself. Is this cola a solution as well?
That's right. Aerated drinks are nothing but gases in a liquid solution. A solution is a homogeneous mixture of 2 or more substances, which means that the density, viscosity, and other physical properties are the same in any part of the solution. For example, a salt solution tastes the same throughout. A solution has a solvent and a solute as its components. A component of the solution that is present in a larger amount is called the solvent. A component of the solution that is relatively present in a smaller quantity is called the solute. A solution of iodine in alcohol is known as a tincture of iodine. The iodine is the solute and alcohol is the solvent. This is an example of a solid in a liquid solution. An aerated drink is a gas in liquid solution, where carbon dioxide is the solute and water is the solvent. Air is a homogeneous mixture of a number of gases. It is an example of a gas in gas mixture.
Now watch as I make this cola disappear.
A solution A solution is a homogeneous mixture of two or more substances. The particles of a solution are smaller than 1 nanometer in diameter, so they cannot be seen with the naked eye. When you direct a beam of light through the solution, it is not visible. Since the particles in a solution are very small, they do not scatter a beam of light passing through the solution. The solute particles cannot be separated from the mixture by filtration. Since the particles are very small, they pass through filter paper. When a solution is stable, it means that the solute particles do not settle down at the bottom of the container even if you leave the solution undisturbed for a while.
I found this bottle of concentrated magic potion among my teacher's things. I'll have a few sips and turn into a powerful magician. It tastes terrible. I hope it works. Let me try making the flowers grow bigger. I think the potion was too dilute.
Concentration is defined as the amount of solute present in the unit volume of a solution. A solution that contains a relatively smaller quantity of solute as compared to the solvent is known as a dilute solution. The concentration of a solution can be expressed using two methods. Mass by mass percentage of a solution is equal to mass of solute divided by mass of solution multiplied by 100. Mass by volume percentage of a solution is equal to mass of solute divided by volume of solution multiplied by 100. Now that you know what mass by mass percentage and mass by volume percentage of a solution means, let's look at situations where these concepts can be applied. A solution contains 20 grams of sodium carbonate in 240 grams of water. You need to calculate the weight percentage of the solution. In the given problem, the weight of the solute, sodium carbonate, is 20 grams. The weight of the solvent, that is water, is 240 grams. We know that the weight of the solution is the sum of the weights of the solute and the solvent. Let's use this formula to solve the problem. The weight of the solute is 20 grams and the weight of the solvent is 240 grams. Therefore, the weight of the solution is equal to 260 grams. We know that weight percentage is equal to the weight of the solute divided by the weight of the solution multiplied by 100. Therefore, we substitute the values of the weights of the solute and the solution in the formula. Hence, the weight percentage of the solution is 8.33%. Let's try out another example. 15 milliliters of hexane is mixed with 45 milliliters of benzene. You want to calculate the volume percentage of the solution. In this problem, the volume of the solute, hexane, is 15 milliliters and the volume of the solvent, benzene, is 45 milliliters. The total volume of the solution is equal to the sum of the volumes of the solute and the solvent. The volume of the solute is 15 milliliters and the volume of the solvent is 45 milliliters. Adding both the volumes, you get the total volume of the solution equal to 60 milliliters. We know that the volume percentage is equal to the volume of the solute divided by the volume of the solution multiplied by 100. Therefore, the volume percentage of the solution is given by dividing 15 milliliters by the total volume of the solution, that is 60, into 100. Hence, the volume percentage of the solution is 25%.
This is fun and so simple. Let me add more salt. I must have messed up again. The salt is not dissolving anymore.
Even if you stir the solution vigorously or wait for a long time, the solution will remain undissolved. You have obtained a saturated solution in which no more solute will dissolve. The solution that we had obtained initially was an unsaturated solution. Now heat the saturated solution. The undissolved solute present in the saturated solution slowly dissolves as the temperature rises. After the solute has dissolved completely, slowly cool the resultant solution to room temperature without disturbing it. The solute, which was undissolved before heating, has now dissolved. This means that the solute dissolved in the present solution is more than its solubility. The type of solution that we just discussed is called a supersaturated solution. In this solution, the solute present is more than in the saturated solution. Even a slight disturbance will make the solute precipitate out, and you will be left with a saturated solution. Therefore, we can classify a solution as saturated, unsaturated, or supersaturated, depending on the amount of solute present in the solution. Solubility can be defined as the maximum amount of solute by weight in grams dissolved in 100 grams of solvent at constant temperature. For instance, at 20 degrees centigrade, a maximum of 36 grams of common salt can be dissolved in 100 grams of water. So the solubility of common salt is 36 grams at 20 degrees centigrade. A suspension is a heterogeneous mixture in which the solute particles do not dissolve and remain suspended throughout the solvent. The solute particles can be seen with the naked eye.
Aha! So that's why when I added chalk powder to the beaker of water, it didn't dissolve.
Exactly. A mixture of chalk powder and water is an example of a suspension. Other examples of suspensions include milk of magnesia, sand in water, and flour in water. A suspension is a heterogeneous mixture. The particles of a suspension are quite large, and they scatter a beam of light passing through the suspension and makes its path visible. A suspension is unstable. When a suspension is left undisturbed, its solute particles settle down at the bottom of the container. The solute in a suspension can be separated from the mixture by the process of filtration.
Let me try a new trick. I'll put some ink into this glass of water. Then I'll pass a ray of light through the glass. I've become a magician at last.
A mixture of ink and water is an example of a colloid. Since its particles are smaller in size than those of a suspension, a colloid seems to be homogeneous. However, a colloid is actually a heterogeneous mixture. The particles of a colloid are very small and cannot be seen with the naked eye. The particles in a colloid do not settle down when left undisturbed. This shows the stable nature of the colloid. Colloids can scatter a beam of light and make its path visible. Particles in a colloid cannot be separated from the mixture by the process of filtration. A colloidal solution has two components, the dispersed phase, and the dispersing medium, the solute-like component or the dispersed particles in a colloid form the dispersed phase. The component in which the dispersed phase is suspended is known as the dispersing medium. You can classify a colloid according to the state of the dispersing medium and the dispersed phase. There can be many types of colloids. The table shows you examples of colloids based on their dispersed phase, dispersing medium, and type. An aerosol is a colloid in which the dispersed phase is a solid or liquid and the dispersing medium is a gas. Smoke and automobile exhausts are aerosols in which solid carbon particles are dispersed in air. Fog, clouds, and mist are aerosols in which water is dispersed in air. Foam is a colloid in which a gas is the dispersed phase and a liquid is the dispersing medium. Shaving cream is an example of foam in which air is dispersed in water or alcohol. Solid foam is a colloid in which a gas is the dispersed phase and a solid is the dispersing medium. Foam rubber, sponge, and pumice stone are examples of solid foam. In foam rubber, the dispersed phase is air and the dispersing medium is rubber. An emulsion is a colloidal system in which both the dispersed phase and the dispersing medium are liquids. The liquid, which is the dispersed phase, is not miscible with the liquid, that is, the dispersing medium. Milk is an emulsion in which the dispersed phase is liquid fat and the dispersing medium is water. Face cream and cod liver oil are other examples of emulsions. A sol is a colloidal system in which a solid is the dispersed phase and a liquid is the dispersing medium. Starch solution is a sol in which starch is the dispersed phase and water is the dispersing medium. Other examples of sols are gold sol, milk of magnesia, and mud. A solid sol is a colloid in which both the dispersed phase and the dispersing medium are solids. Ruby glass is a solid sol in which gold is dispersed in glass. A gel is a colloidal system that contains a liquid as the dispersed phase and a solid as the dispersing medium. Jelly is a colloid of water dispersed in gelatin. Curd, cheese, and butter are all gels. When a fine beam of light has passed through a colloidal solution placed in a dark place, then the path of the beam gets illuminated. The illuminated path of the beam is called the Tyndall cone. This phenomenon of the scattering of light is called the Tyndall effect. The Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. When sunlight passes through the canopy of trees in a forest, you can see the Tyndall effect at work again. In the forest, mist contains tiny droplets of water, which act as particles of colloid dispersed in air. In solutions, the particle size is 10 angstroms. In colloids, the particle size ranges from 10 angstroms to 2000 angstroms, while the particle size is greater than 2000 angstroms in suspensions. The particles are invisible in solutions, while the particles are visible in colloids and suspensions. Particles in solutions and colloids pass through filter paper easily, while the particles in suspensions do not pass through filter paper easily. The Tyndall effect is not observed in solutions and suspensions, while it can be seen in colloids. A solution is a homogeneous mixture, while both suspensions and colloids are heterogeneous mixtures.